Right, so here we have a shape of a trapezoid, and back in geometry, you should have learned about the area of a trapezoid. So we're saying, all right, let's go ahead and find out the area of the trapezoid. What's the equation again? Area is base 1 plus base 2 times height and divided by 2. Well, of course, my primary concern would be, do you know the equation of the trapezoid's area? And I would say the area of a trapezoid belongs to the category of equations that you should know for the rest of your life, along with equation for the formula for the area of a rectangle, circumference, area of a circle, area of a triangle. Just the typical one, okay? The 1/2 base times height, okay? Okay, so now my secondary concern is, do you know what is the base 1 and what are the base 1 and base 2 here? Base 1 would be, base 1 is, you can do 10. And if you do base 1 is 10, the base 2 would be 7. So these are the two bases because we kind of put the trapezoid sideways. So make sure you know how to tell the base 1 and base 2. So to find out the area, you just need to add the 7 plus 10 together times 20 divided by 2. So you don't need to use a calculator for this one because you have 17 times 10 because you can reduce 20 and 2. Again, you always reduce before you multiply. So you have a area of 170, okay, units square. Easy? Okay. Now, if you understand this little equation, this little area of a trapezoid, then I want you to draw the same trapezoid, but you label the sides a little bit differently. Okay, you draw the same trapezoid, but you label the sides a little bit differently. And this would be these would be the labels. The left base would be base A1. The right base would be AN. And your little height should be N. And I would say, all right, guys, please go ahead. Use these terms, use these labels to find out the area. Okay. So how would you express the area using these labels? A1 plus AN times N over 2. Okay. So if you look at this, you look at your paper. Okay. You look at your paper, and then you pan your vision slightly to the left, and you see this equation. And now you look at this equation, and the area equation we just wrote, are they the same? Okay. So what I want to introduce to you is actually a very simple idea, but for some reason they don't talk about it textbook-wise. Okay. And this idea is actually very crucial when you go to the next course, which is calculus. Okay. So what we're doing here is we're trying to add up some numbers. Okay. And when we say, oh yeah, please go ahead, we have a list of numbers. We call it arithmetic sequence, and we're going to add some numbers together. Well, how? Well, we say use this equation. But where does this equation come from? It came from the trapezoid. So what's going on here? It's basically asking you to do a very simple thing, and that is you have a curve. Okay, a curve that's made by 2 points. The value of A1 and the value of AN. And we say that, well, if you have these 2 points, can you find the total? And to find a total, it's practically finding the area under the curve. Okay. Now this idea would come to you again, and I hope you'll remember me and miss me when you see this again in calculus. Now in calculus, you will see something like this. So just to give you an idea, that in calculus, we want to do one thing. We want to estimate the area under the curve, but you know, it's a curve. How would you do this if it's a curve? Well, we used to use, well, at the very beginning, we would say, let's use rectangle. Rectangle is easy. The area of a rectangle is just base times height. But then if you look at the rectangle here, you'll be like, wait, see those gaps right there? That's not good. We are underestimating. So then we ask a very natural question, and that is, can we estimate better? And we say, sure. We just don't use a rectangle. What do we use? Well, guess what? We use a trapezoid. So by using a trapezoid, we kind of optimize this approximation process. So that's where you will see trapezoid again in the next course. And that's why I would say it's important to know what the formula for the area of a trapezoid is right now and for the rest of your life, so that you won't find yourself at a very difficult position next year. Okay. And when you talk about series, you'll see that more if you take calculus 2 in college, but they're all related together. Okay. So for now, I just want to make sure that you have a little idea of trapezoid. You can visualize things as a trapezoid. And if you can visualize it, then this equation, very easy to stick in your head. Okay. So now let's look at a couple examples here. Okay. So look at the first example here. We have a list of numbers. The first 4 given. We say, all right, you have 5, 9, 13, 17, and so on. And we say, all right, could you please go ahead and add up the first 20 terms? Okay, well, if you give this question to an elementary school student, what would they do? Yeah, they'll write out all 20 terms and then using a calculator, just punch in the keys and find a total. That would take you about maybe 5 to 10 minutes. You know, writing it's intensive. But we're pre-calculus students. So we have to, we could do something a lot easier, a lot faster too. So the way we think about this is, all right, do we have a way to find out what the 20th term is? And then we can visualize it this way. We can say, oh yeah, so you have A1, that is 5. And then you go 20 terms all the way to the right. And then you have the 20th term right here. And basically you're finding the area of this trapezoid. So what is the 20th term? Well, an elementary school kid will write out all 20 terms to find out the 20th term, but we don't, because we can find out the nth term expression. So what's the nth term expression? Well, starting with 5, so you know A1 is 5, and then you're adding 4. So that means it must be 4n. Okay, plus something. Plus what? Not 5. 4n plus. Now, so I'm gonna leak the shortcut to you. Just think about this. You have your A1 equals to 5. So if n is equal to 1, what do you need to add so that you're gonna get a 5? 1. Because when n is equal to 1, 4 times 1 is 4, plus 1, you get you 5. Okay, so that's how you can get to the nth term notation a lot faster. It's kind of like thinking backward. Okay, so this is your nth term, and then you want to find out the 20th term. Well, what's the 20th term? 81. So you're practically finding the area of this trapezoid with two bases being 5 and 81 respectively, with a height of 20. So the notation we have here is S20, which is the sum of all 20 terms. It's equal to 20 over 2, okay, times 5 plus 81. I don't think you need to use a calculator for this one because 20 divided by 2, it's 10. And 5 plus 81, it's 86. So the total is 860. Okay, 860. All right, so I would really hope that you can visualize the trapezoid. If not, just go ahead, use the formula up there, plug it in, you're good. Okay, questions? Good. Okay, so next one. It's you have 17, 14, 11, 8, and we're saying, hey, go ahead, add up the first 25 terms. Well, again, we're not elementary school students. We're not going to write out all 25 terms to find out the 25th term here. So we say, let's go ahead and find out the 25th term here through the nth term expression. So we say, well, we have A1 being 17, and every single time we go to the next term, we are subtracting 3. So the D is -3. So we have -3 n plus what number? 20. Okay, with 20. So that's your nth term expression, and we need to find out the 25th term. So you have -3 times 25 plus 20. That would give you a -75 plus 20. That is -55. Okay, -55. Well, that's the 25th term. So again, you can use the formula to find out what the S25 is, or you can visualize this as a trapezoid, which I can draw you here. So for this one, it could be a little bit challenging to see it because the numbers are kind of weird. You have 17 over here, and then you have 25 for this, but then actually, you want to do it the other way. So this is 17, and then this is -55. You can look at it this way. Okay, so you have 25 divided by 2, and then 17 plus -55. Okay, your first term is 17. The 25th term is -55. So insert those numbers and see if you can do it without a calculator. So 25 over 2 times negative of 38. Okay, 17 minus 55 is -38. So you have 25 times -19. Now, how can you do this calculation, do this multiplication very quickly? Louder? 40 times 25? You said something, I think, wait, say it one more time.
I said just -40 times 25 over 2, and then just add another thing.
Oh, okay. You can do that, or there's an easier way. 25 times 20 first, which is 500, and then minus 25, which gives you 475. Okay, I think you get the idea, same idea. Okay, so this is a lot easier. Okay, this is a lot easier to handle. Okay, Like in middle school or elementary school, they taught you this, right? Well, you would do this when you were in elementary school and middle school. We don't do that in high school because that's too slow, okay, and not too smart. Okay, this one is way smarter. You times 20 and then subtract 25. Okay, so that's the total, negative 475.